Hey there, hope everyone's doing well. So this video we're going to talk more in depth about class constructors and hopefully demystify a little bit about what's going on in there. A couple sources for this video. The code that I'm going to do at the end of the video, it's already pre-typed out. I didn't want to waste your time as I typed everything. However, it is up here on the Project Full Stack GitHub, so if you want to go there, you can copy and paste it or look at it in another monitor and type it out yourself, which is what I would recommend. And then we have the Python documentation on classes. You'll see me some screenshots come directly from this, and I'll probably bring it up a little bit and talk about it as well. All right, just a quick recap, classes versus objects. So remember, a class is the overall blueprint of something, right? A class is going to be where we define what properties something should have and what functions or methods it should have. Whereas an object is an instance of that class. Multiple objects can be created from the same class. Each one of those objects from the same class is a completely different spot in memory. And altering one object doesn't necessarily alter the other objects unless you specifically design things to do that, which we're not going to do. So again, my little cup example, I have two objects. They're both coffee cups. They're both derived from some class that created these coffee cups. I can alter the state of the one on the left. I can drink from it, and it doesn't change the state of what's on the right. So basically, what is state? This is a Wikipedia definition. A system is described as stateful if it is designed to remember preceding events or user interactions. What that really boils down to is, similarly, a computer program stores data in variables. We should be familiar with that. Those variables actually just represent some type of spot in memory. They represent storage locations in the computer's memory. The contents of those memory locations at any given point in the program's execution is called the program state. Okay, so all your state is basically whatever variables and anything you have defined in your program at that time and what they equal to. So when I talk about an object state, I'm talking about the object in memory and what we have defined on it and what the values are for that. Quick recap on creating a class here. So here's your syntax for creating a class. Right, you have the class keyword, so this guy in green right here, followed by a space. You have to have a space in between the keyword, and then the name of your class. In this case, I use class name. Again, this is camel case. So camel case just means when you're, doing your, any name that has multiple words in it, you're basically gonna capitalize the first letter of each word. Looks like humps on a camel in theory, so that's why it's called camel case. And here we have the my class again. We have the class keyword, followed by a space, followed by the name, followed by a colon. That is required. Then everything underneath that class, any properties or methods for that class, need to be indented underneath it, just like everything else in Python for these compound complex statements like class definitions. All right, everything needs to be indented underneath it. Now, what is the constructor? Okay. It's this function right here. It's a special function called underscore underscore init underscore underscore. It's going to take self as the first parameter. It absolutely has to take self as the first parameter, and I'll show you why when we code. Then it can have any other kind of comma separated list of parameters like you're used to for any other functions. And basically, we are going to use this init to initialize a specific state for a new object. So init is being ran every time a new object's created. The self is going to point to the object that's being created. And we can use dot notation to assign new properties to that object. So basically, every single time this init function is ran, whenever we create a new object from the complex class that's defined right here, we're going to come in here and we're going to say that object that's being created, assign a property R to it, and the value of that is going to be whatever we passed in for this real part parameter. Then on that same object that's being created, assign a new property, I, and assign that, or the value of that, to whatever we're passing in for image part. And that's how you get down here. You say x, so we're creating a new variable called x. We're setting it equal to, so we're assigning the value of, okay, here's our how we create an object from the complex class. We're passing in for the first parameter. Remember, you don't pass in self. If it's implicit and it points to the object being created. So we're passing in 3.0, so that's going to be the real part. Then we're going to come down here and we're going to assign that property R on that object, and it's going to equal that 3.0. And we're going to do the same thing for this negative 4.5. Pass it in for the image part parameter, which is then going to come down here and be assigned to the I property on that object we're creating, which is why when they print out right here x.r, it equals 3.0, and x.i, it equals negative 4.5. We're going to see this more in action, and I'm going to step through it line by line. All right, so let's just go ahead and program here. What I did for this was not that one, I did this. So basically, what I wanted to do is think about students, right? An individual student is going to have a name. An individual student's going to have an age. They're going to have some type of unique student ID, and they can be registered for some type of courses. So just think of like a college student, a high school student, or something like that. Okay, and we can do this in lists. Okay, that's one thing to remember. Object-oriented programming is a paradigm, right? Fancy word for saying it's a model or it's a way of organizing your programming. You don't have to do things in an object-oriented format. I can just create a list of students, and then I can come down here and I can reference these students just like I normally would. And if I run this code, I get Joe 18, 8429, and a list with Math 401 and Comp 405 in it. Okay, that's because I have a list, and each one of these indexes in a list is another list with all the properties that I want my students to have. The first index of that is going to be the name. The second, the next index is going to be the age. The next index is going to be the student ID, and then the next index is going to be the courses that are registered. Okay, and then I'm just coming down here on line 18. I'm saying, hey, go into that students list, get index 0, which is going to be this index right here, and I'm assigning that list to the property Joe. So then when I say print Joe 0, we're printing the 0 index, which is the name. Print Joe 1, we're printing the number 1 index, which is 18, so on and so forth. So that's how I get printed out Joe 18, 8429, and the courses. Okay, but we can organize this in an object-oriented format as well, and it's going to make much more sense, because what happens if hundreds of lines down my code here I'm trying to get Joe's student ID? I have to remember that that is the second index in the list, and maybe I don't remember that. I forget about it, and I actually try to use Joe 1. I could have all sorts of errors in my programming. So this completely does work. There's nothing necessarily wrong with it as long as you manage your code correctly. However, it's much easier to manage when we do it as in an object-oriented format. So this is what I have here. I have a class called student. Let me get rid of this project pane here. I have a class called student, and basically the same module level, or excuse me, class level docstring, right? It represents a student. The public properties that we're exposing are a name, age, student ID, and registered courses. We should actually, for better consistency here, we should have in the docstring the actual property name that we're going to assign these to, which is, that's courses, okay. All right, I have my constructor. Remember, 2 underscores here, so it's not just a single underscore, it's underscore underscore init underscore underscore. It's a special function here. Has to take self as the first parameter. Then it takes any number of parameters, comma separated parameters. Inside of the init function, what I should do here, this is make a little, I'm not going to do that because that's a lot of docstring right here. But this is just the constructor for the student class. In real programming, I would have all that doctoring stuff in there, but right now for this little thing, I'm not going to bother. Okay, so every time we create a new student, we're going to run through here and we're going to assign properties to that object in this constructor, and they're going to be set to whatever value I pass in, right? Name, age, student ID, courses. So here on line 26, I'm creating my first student object. Okay, we're going to go over here and I'm going to pass in Joe is going to be passed in for the name parameter. 18 is going to be passed in for the age parameter. 8429 passed in for the student ID parameter. And, this list with Math 401 and Comp 505 passed in for the courses parameter. Then we're going to do some print statements. And then I basically do the same thing for Jane. I'm going to create a new object. Remember, these are going to be completely separate spots in memory with their completely separate states. And I'll prove that here. Okay, and Jane's got Jane. She's 20. 2931's her student ID and signed up for History 420 and Comp 505. And then I messed this up. This should be printing Jane courses and name. So, all right, let's just run this and see what happens. Okay, so we ran it. We printed Joe 18 8429 and what Joe was assigned. And then we have for his courses, and we have Jane 20 2931 and Jane's courses. Okay, there's our print statements for Jane, our print statements for Joe. Now let's actually step through this line by line. I'm going to throw some breakpoints in here. You probably can't do this with your editor unless you know how to set it up. So you don't need to even try to do this. However, I just want to throw these out here and show you what's going on. So let's run my debugger here. All right, so right now I just created the file, right? We skipped all these comments here. The debugger's coming down. It's breaking on line 7. It's saying, okay, at this point in time, the only things that exist in the state of my program, all my variables, right, is whatever Python comes with on default. Okay, just a bunch of special stuff that's, already there when Python creates a module. It's done behind the scenes. I haven't programmed any of this. So let's step forward to the next line. All right, so we're on line 26 where we're creating the Joe object. Okay, now what I want to show you is I'm gonna step to my next line and we're gonna jump up here in the code because I'm creating an object of the Joe class. And the init method is ran every single time that we create a new object for this. So I'm going to step forward. You're going to see this highlighted line jump up to line 20. Okay, I'm inside now of the init function. What I want you to notice is what is self. Right now, self, it's right here in my debugger. It doesn't have any properties, but it does have a memory ID. I'm going to copy and paste this down here just for reference. Because I want to be able to prove to you that Jane has a completely separate memory address. So right now, this is where Joe's memory address is saved. Joe technically doesn't exist at this point yet, because how Python works is with assignment statement. We're going to execute everything that's on the right before we execute the assignment statement. So right now, all we have is this self variable right here that has no properties with it, because we're at line 20 and we haven't executed line 20 yet. However, when I press to resume my program and step to my next breakpoint, the next line, watch what happens. Now we took that self, which pointed to this location in memory, we assigned it a property called name. So name is created on that object, and the value of that variable is whatever we passed in for the parameter. Passed in Joe right here. It's passed in for that parameter, which is that value right there. If I step forward again, you're going to see age pop up because we're going to assign the vet property age to this object, self, which is going to equal whatever we passed in. So there's age. Let's do it again. Now we should see student ID pop up. There it is. And now we should do it again. And my code's going to jump down here because I'm done creating the object. But I want you to see something real fast is watch what happens. I resume. Now I have, since I've gone down to the next line, I created my object over here, and then init assigned that object that was created to the variable Joe. So Joe has age, it has courses, which is just a list of strings, name and student ID, and notice the memory ID. It ends in 0 or 130. That's the same memory ID that we said was the value of self when we were inside of this function. We do a bunch of print statements. We come down here to Jane. I'm just going to step through these. All right, Jane, we should see this whole process repeat itself. Okay, let's step forward. We jump into the init. Now, self for Jane points to, notice that, this one ends in 040, whereas this memory address ends in 130. So the self variable inside of this init function, the second time I ran it, points to a completely different spot in memory. Let's throw that down here just as a comment to keep track of it. And then it's going to go through, right now the self doesn't have any properties, but we're going to tack those on as we go through the constructor and assign those properties and whatever values we passed in. And then we're going to jump down here, and now Jane exists. It's a student object. All right, it says right there, student object for Joe, completely separate spots in memory. And when I do my print statements, you just saw that I get completely different values. All right, I can run it right here. And here's all my Joe print statements. Here's all my Jane print statements. And just to show you, I'll do this real fast, just to show you that I can interact with these. So let's change Jane's name to just something. It doesn't matter, right? And let's print out Jane's name again, right there. Let's run this. Okay, that's where I printed out her name the second time after I changed it to this nonsense. Let's just set our debugger down there, and then we'll be done this video. All right, I'm gonna break here. Remember, breaking means go to this line, but don't execute it. Let's debug it. Yeah, I had a breakpoint there too. All right, so as right now, before I've changed Jane's name, I've got two objects, Jane with the name of Jane and Joe with the name of Joe and all their other specific stuff. I'm gonna advance to the next line. As expected, Jane's name changes to that nonsense I passed in. Joe's name down here is altered, right? Or excuse me, it's not altered. We're not messing with the state of Joe at all because they're completely different spots in memory. If you are confused of why their memory address changed, like for Jane, we said it ended in 040 the last time I ran it, and Joe ended in 130. They're different memory addresses now. That's just because I just reran my program. It doesn't obviously save. Once you close your program, all that memory is freed up. So, but when you do run it the first time here, all of those are completely separate spots in memory. So that is what's going on with the constructor, and that's how you're creating new objects with completely separate spots in memory and completely separate states, and the constructor is what you use for initializing and setting that initial state for those objects. Let's see, I think that's all we got for this. All right, cool. Next video, we'll talk a little bit more about, we talked about properties. Now we'll talk about object or class methods.